Hello and welcome to the fifth tutorial in the R intro sequence for Bio 170. I'm Israel del Toro. I'm the professor and instructor for this course. So today we're going to be working primarily on plotting out the distribution of data. And to do this, we're going to use the library ggplot2. So I've taken the liberty of cheating a little bit today. And I've written up my code beforehand, but don't worry, I'm not going to rush through this, and this code will be available to you at the bottom of this tutorial video. So no worries, follow along at your own speed. All right, first things first. Before jumping in, one of the first things I like to do is set my working directory. So for today's lab exercises, I've gone ahead and made a new folder inside of my desktop. And this folder is called R group, and within it there's a subfolder called week 2. This is where all of our outputs are going to go as we build them today. The next step in this bit of code is, after you run your working directory, is to load in your libraries. And remember, your libraries are just a set of functions. These allow us all of the functionality that are nested within the library of this, in this case, of the package ggplot2. Today we're not going to go ahead and make up data, but rather we're going to use data that's stored internally inside of R. R has several hundred data sets that you can play with and are used as examples all the time. Today we're going to load in a data set called iris. We do this by using the function data and then the name of the data set, in this case iris. Once we've done that, we'll see that iris now has populated my global environment, and if I click on iris, we should be able, if we're curious to see what iris actually is, we can ask R directly what it is by doing question mark of iris. Now this shows us that iris is, this basically gives us a description of the information that is in the dataset iris. It's basically a morphometric data set for 3 species of iris: Setosa, versicolor, and virginica. Now we can also view some of the inputs of iris by looking at the first 6 rows of it. And this shows us basically what this data set looks like. We have sepal length, sepal width, and then the species. We can ask R what the structure of these data are, and it tells us that it is a data frame with 150 observations of 5 variables. Some of these variables are numeric, like those first 4, and others are factors or categorical, which in this case is just species. All right. Perhaps the most commonly used form of viewing data is to view it as a histogram. ggplot allows us to make histograms pretty easily. All we're going to do is build our first plot here. And what I want you to remember about building plots with ggplot is that you're essentially building them in layers, one layer at a time. Sometimes you tell ggplot what type of plot you want to add, whether you want to add lines, change colors, change text, add labels. All of those are different examples of layers that could be added to a ggplot graph. We'll start off with a histogram, and we'll start off with the first line here, line 12, that says ggplot, and we're going to designate our data source, which in this case is iris. Line 13 here then tells ggplot what type of plot you actually want to build. In this case, the geometry that we want to add is the histogram, and we want to add some aesthetics. What's actually going to populate that plot? In this case, let's say we wanted to populate this plot with petal length. And because histograms, you can play with the bin width or the number of bins that the data can fall into, we can manipulate this variable quite easily, and we'll see what that looks like in just a second. All right, let's run that line of code. And this creates our very first histogram. And so what we see here is this nice bimodal distribution, and this is taking into account all of the data within this set. Any ideas what could be driving this difference? Well, maybe this difference is driven by different species. Maybe one species has a very different petal length than some of the other species. Now we can also change the bin width. This is the variable I encourage you to play with, and see how this changes the histogram distribution. Let's say we changed our bin width instead of 0.1 to 1. Still has this slightly bimodal distribution, but we're starting to lose the pattern. If we increase it by a factor of 10 to 10, we're really starting to lose our pattern. So let's go back to where we started, because that was the best looking histogram that reflects the true distribution of this data. We can also go the other way, and we can still see that same shape tends to hold true. We have this bimodal distribution, but we don't know very much yet about what could be driving this potential bimodal distribution. So for this, we're going to use a density plot. And this is sort of my favorite way of visualizing the distribution of data in R. We're going to go ahead and create a density plot of the same variable, petal length, adding the geometry geom density. And in this case, we're going to add one more layer that sets our limit, or the limit of our x-axis, between -1 and 10. Let's see what a density plot looks like now. Okay, so now we have this bimodal distribution again. On the x-axis, we'll see that we have the range from -1 all the way to 10, and this is plotting out petal length. Great, so this is a slightly smoother way of visualizing the data. I encourage you guys all to spend some time playing with different parameters that will allow us to explore this data set a little bit different. The ones I recommend playing with are fill, alpha, theme, and lab. If you're curious to see what each one of these does, all you have to do is ask R using the question mark command. I've gone ahead and modified each of these variables, and I'll show you what my final plot looks like. So here what I've done is I've created a new object called density plot, and now I've saved it as a new object, and you can see that's populated my global environment. If I want to view it, all I have to do is type density plot, and here is our plot. And indeed, it looks like one of our species, Setosa, has a much different petal length than versicolor and virginica. Okay, let's say you wanted to save this file. I'll show you the quick and dirty way of doing it today, but there will be an additional instruction tutorial down the line on how to export high resolution images. So for today, all you have to do is go to your viewer or your plot window, click export, and you can save it as either a PDF or an image. I'm going to save mine as a PDF today. What's cool about this is that the directory is automatically filled into wherever you set your working directory, and then you can call this whatever you want to. Let's try density plot. You can also change the size of the PDF, whether it's portrait or landscape, and so on and so forth. Click save, and now if I just navigate out to my working directory, week 2, we'll see that density plot PDF is now saved on there, and we have a copy of what we've just created. All right, that's all I got for today, and join us next time for a new tutorial. Cheers.